Hi, Marty Dwyer with Boat Anchor Audio. A while back, we posted several videos. They were audio filters. One was a fixed frequency filter, and the other was a variable audio filter. They worked out pretty well, especially the fixed frequency one. It had 6 fixed frequencies in there, and it was designed as a bandpass filter to reduce the total harmonic distortion of audio oscillators that are not lab quality. The idea was to get the TH down to a level of, say, 0.003%, something like that. The fixed frequency one worked very nicely. The variable frequency one left a little bit to be desired, the main problem being that it was very difficult to tune the frequency. We did a little bit of work, a little bit of redesign, and we came up with a modification of it. The essential circuitry is the same. It's a state variable filter. It will have 3 outputs: low pass, band pass, and high pass outputs. It has a variable Q, variable gain, and an adjustable damping trimmer resistor, trimmer pot. We'll cover a little bit later. All right, first of all, let me show you the schematic. Extreme left, we got J4. That's merely nothing more than your standard RCA jack. That's the input. Goes to a gain control, gives you variable gain. You have a Q resistor Q pot in there. We can change the Q of this. At the very top center, you'll see a switch in 2 segments. It's nothing more than a 6-position 2-pole switch. Now, why did we use a 6-position switch when we're only using 3 positions? The answer is very simple. It keeps the inventory very simple. We can always substitute a 6-position switch where a 3-position switch is needed, so there's no problem there. If you look closely, you'll see 2 pots there. They are RV3 and RV4. They are dual pots, and they control the frequency. One is a course adjustment. The other pot, which is merely in series with the course adjustment pot, the other pot is a fine adjustment. Makes these things a lot easier to tune than our original one. The original one worked very fine, but it was a dog to tune to get to the right frequency. Anyway, continuing over to the extreme right, we have low pass, band pass, and high pass filters. Again, they're nothing more than simple standard RCA phono jacks. At the bottom, in the center, we have J5. That's merely a 2.1 millimeter jack that will accept a standard 2.1 millimeter plug. Going a little bit further, we have S3. That is your on and off switch. As you can probably see, we use a double pole, double throw switch. Why did we use that when we can simply use a double pole, single throw switch? Again, it keeps the inventory simple. Continuing a little bit further, we have D1 and D2. These are nothing more than polarity protection diodes, so you don't blow this thing up in the middle of the night when you haven't had enough coffee. Going a little bit further, we have a rail splitter. Now, I feel a lot more comfortable working with an op-amp that's powered with a split rail supply rather than a single-ended supply. Everybody has their own way of doing it. Good for them. I like using this. The design is a little bit easier, and it may arguably be a little bit more stable. That's neither here nor there. Anyway, you can see the various filter condensers in there. And we also added a couple of caps, which are not shown, that go directly to the IC socket. So we have different size filter caps in there. You want to keep the noise level down as low as possible. Again, these signal levels are very low, sometimes as low as 500 millivolts. So we don't want any noise, any garbage in there. Looking over at the extreme lower right corner, you'll see an unused op-amp. Now, as you all know, the TL074 is a 4 op-amp chip. We're using 3 op-amps. We have a 4th op-amp unused or uncommitted. I think that is the latest buzzword. Anyway, it's been properly terminated, so this thing doesn't go off to la-la land. It's not going to cause a problem. However, we terminated it with jumpers. So later you could take this op-amp, which is unused, and use it as a buffer or use it as a small amplifier, as you may please. Okay, we looked at the schematic. Now let's take a look at the finished product here. What we have are a number of controls and a number of jacks. So let's take it one by one. On the left-hand side, you have a silver control. That's merely the audio gain. Right next to it, there's another silver control. That is the Q control. Next to that, we have a black knob. That's the fine tuning. And to the right of that, we have another black knob. That's the coarse tuning. At the top, we have a black knob. That's merely a 6-position rotary switch. However, as I've mentioned, in order to keep the inventory simple, even though we need 3 positions, we use a 6-position switch. It has 3 ranges, beginning at 80 cycles and stopping at around 20 kcs. To the immediate left of the range switch, we have a black jack. That's merely a 2.1 millimeter power jack. This can be powered by anything from 15 to 24 volts. Now, if you're using this for a high pass or a low pass filter, you probably don't want too much damping in there. However, if you're using it as a band pass filter, you may want to get a higher Q. So in conjunction with the Q pot, you can use that trimmer pot to give you a relatively high Q. Now, you don't want to go crazy on this. If the Q is too high, this thing may go into outer space and start to oscillate. So you have to use a little common sense here. It's just like an amplifier. If you crack up the gain too much, it's probably going to get a little bit of distortion. All right, let's see how this did when we ran it through the test equipment. By the way, what we're using is the Digilant Analog Discovery 2 with the waveform software, which in my opinion is a nice combination. Anyway, take a look at the first result here. This is, as you can see, it's a low-pass filter. It's centered on 1 kc. It's a 2-pole filter, and as a 2-pole filter, it rolls off at 40 dB per decade, as we expect. There's minimal, or the dampening is set, so everything rolls off smooth as possible. We don't have any bumps. We don't have any sags at the corner there. It's probably the way most people would want it. Now, the next one we have is a high-pass filter. Again, it rolls off, since it's a 2-pole filter, at 40 dB per decade. Again, we have the R3, the dampening trimmer, set so it rolls off nice and smoothly. No lumps, no bumps. Again, that's probably the way most people would want to use a high-pass filter, as they would with a low-pass filter. All right, the third result here is the band-pass filter. Now, we have 2 of them to show you, 2 results. The first one is with the Q relatively low. And some people may want a low Q for a particular project. On the other hand, maybe they want a higher Q. So the second result here does show a higher Q. Now, in combination with the Q control and the dampening control, you can adjust your Q pretty high. Again, the caveat is you don't want to go into outer space with this thing. It may take off on you if the Q is too high. A high Q might be used for, again, for reducing the THD of something. As an example, an audio generator that's not state-of-the-art, you can adjust this so you get the Q or the THD down to maybe 0.003, 0.004%, which is fairly good. It's in the range of a lab quality generator. Anyway, that's our new audio filter. It's tunable from about 80 cycles up to 20 kcs. Has 3 ranges: adjustable gain, adjustable Q, adjustable damping, for those who need a damping control. And we found it does work fairly well. By the way, the input voltage is anywhere from about 15 to 24 volts. It's not that critical. It draws 8 to 10 mils under full load, so it's battery operated. We can operate it. We have operated it with the battery, and it works very well. We've operated it with a bench supply. Again, it works very well. Anyway, we hope you found this interesting, and in the meantime, keep those electrons flowing. Talk to you later.